Homework 1, Polynomial Functions, Video 1. In the previous series of videos for Homework 10, we discussed quadratic functions, which by definition had a highest power of x squared. We could look at cubic functions, meaning that the highest power is 3, or what are called quartic functions, Q-U-A-R-T-I-C, which the definition of is the highest power is 4. But there's really no need to stop and rediscover the wheel every time we tack on one higher power. Once we get beyond quadratic, once we get beyond x squared, then we can talk about polynomial functions in general. A polynomial function is a function of the form f of x equals some coefficient times some power of x. We'll call the highest power x to the n, and we'll call its coefficient a sub n, subscripted to match the power on the x. But I digress. A function of the form f of x equals a sub n times x to the n power plus the term with the next lowest power and its coefficient, a sub n minus 1 times x to the n minus 1 power. Excuse me. Grab a Kleenex real quick. Allergy season. I know that's not what everybody's worried about right now, but it's an issue for me. After the second term, then there are some more terms, and they basically keep going until we run out of x's. So the third from the last term would be a sub 2 times x squared. The second to last term would be a sub 1 times x to the first, but we don't need to write the first power. And the last term would be some constant, which we're going to call a sub 0. 0 because there are no x's on there, or technically speaking, you could append x to the 0 power because anything to the 0 power is 1, and of course 1 times anything is itself, so there's no need to write that. Don't let this notation intimidate you. It's just a way to generically say a polynomial function is a function that starts with some power, with some number in front of it, and as the powers go down, we pick up more and more terms, each which have numbers in front of them. The numbers can be positive, the numbers can be negative. I keep saying numbers, I should say coefficients, so let's try that again. A polynomial function is just a function that starts with some highest power of x with some coefficient in front of it, and then the powers of x just keep going down. Each one has a coefficient in front of it. The coefficient can be positive, the coefficient can be negative, the coefficient can even be 0. For example, if this coefficient in front of the x squared were 0, there would be no x squared term. So sometimes some of the terms are missing because their coefficients are 0. I also need to introduce a little bit more vocabulary. When you have a polynomial function, the highest power is called the degree. So if I ever say a third degree polynomial, I mean the highest power is x to the third. Or if I said it was a polynomial of degree 7, that means that the highest power would be x to the 7th. The coefficient in front of the highest power, which we're generically representing as x to the n, and so that coefficient is a sub n, is called the leading coefficient. It's called the leading coefficient because if you write your polynomial starting with the highest power, it's the number that leads it off. So the number that represents the highest power is called the degree, and the number that represents the coefficient in front of the x with the highest power is called the leading coefficient. Now, I'm going to be referring to the leading coefficient quite a bit in some subsequent videos, so instead of writing out leading coefficient, I will just abbreviate it capital LC. Caution. The terms of a polynomial function are normally written from highest power to lowest power, but they don't have to be. They can be written in any order. So as I show you some examples of polynomial functions, their degrees, and their leading coefficients, I'll show you variations that are standard from highest to lowest powered, non-standard, and even factored. For example, let's consider the polynomial function f of x equals 7x to the third power minus 5x to the second power plus 4. There's a lot of easy questions I could ask you. I could ask you what the degree equals. That's the same as asking what's the highest power, 3. Which reminds me, before I go any further, I do need to make a stipulation about the power. We kind of assume this all the time, but since we're defining a polynomial function, it is worth mentioning that the degree has to be a whole number, which means no decimals, no fractions, no negatives. It has to be at least 0. If the degree were 0, then the polynomial would start and stop with its constant term at the end. Let's get back to the example. For this polynomial function, the degree is 3, but what is the leading coefficient? The leading coefficient is the coefficient of the highest power. The highest power is x to the third, so the leading coefficient is 7. I know we're not quite there yet, but could you tell me the y-intercept? We've discussed y-intercepts before, and I've told you that they're going to be a recurring theme. Recall that if you are a y-intercept, you are on the x-axis. And if you are on the x-axis, then your x-coordinate must be 0, which means to calculate the y-intercept, you have to let x equal 0. So in other words, we just have to substitute 0, which is really easy in this function because multiplicatively, 0 kills everything it touches. So gone, gone, and the only thing left is 4. Could we find the x-intercepts? Not easily, and for this one, maybe not at all, so we won't go there quite yet. Let's try another one. G of x equals, let's say, let's see, I'm trying to build something here. Let's say 18x squared minus x to the 4th. Yeah. What is the degree of this polynomial? Remember, degree just means highest power, and so the highest power in this polynomial function is 4. But what is the leading coefficient? It's a common mistake to say 18 because it's the first number, but that's not what makes a leading coefficient a leading coefficient. What makes a leading coefficient leading coefficient is being the coefficient of the highest power. And the highest power is x to the 4th. So what number is in front of x to the 4th? You don't see 1 because it is 1 with a negative. So the leading coefficient of this polynomial function is -1, the coefficient of the highest power of x. What's the y-intercept? Well, if we insert 0, we'll get out 0. This one we could actually find the x-intercepts, and I challenge you to find them. I will remind you that if you are an x-intercept, then your y-coordinate must be 0, and in a function, the y-coordinate is the output, meaning that for the x-intercept, we have to solve 18x squared minus x to the 4th is equal to 0. It's actually pretty easy with a little bit of factoring. We'll look at this example in another video when we actually find the x-intercepts. Let's take a look at one more example, because as long as your polynomial function is just sitting there showing you all of its terms, it's really easy to locate the degree, and it's really easy to locate the leading coefficient. But we are going to run across some polynomial functions that are already factored. For example, let's take h of x equals 3 times parentheses 2x plus 1, and outside the parentheses squared, times -x plus 4. That is a polynomial function. Although it does not look like this, the definition, we could, you know what, I think this one is going to merit its own video, so we're going to pause this one and start the next video with this example.